All right, so we have another coordinate geometry question now we're going to solve here. Lines L and M are drawn on the square grid below. So we have two lines, L, this one, and M, right? That's this one running this way. What we need to do, right? They want us to write down the coordinates of the x-intercept and the y-intercept. They want the equation of the line, or they say the equation of the line L is this. So this is not in the correct format. It's not in the form y is equal to mx plus c, right? Find the value of k given at the point 9k lies on the line. So we need to rearrange this so that y is the subject and we move everything else across so we get y is equal to mx plus c. Before we could figure this part out, they want us to find the equation of the line M in the form y is equal to mx plus c. Right? To do that, we know we have to work out our gradient. And we're choosing any point on the line M in order to find the equation of the line. Show by calculation that the line L and line M are perpendicular. Basically, for this one, you want to multiply the gradients. So M gradient, or we could say gradient for M, multiplied by the gradient for L. When you multiply those two together, you should get -1. Right? So we just need the gradients of the two. Line L and line M represent the graph of our pair of simultaneous equations. Using the graph on page 11, which is the graph that I have above there, write down the solution to the pair of equations. Now, using the graph to find the solution to the equation, we're just looking at the point of intersection. So that's an easy fix there. So let's start working on this question. I'm going to write on the side here, okay? So the first thing now we need to work out is the x-intercept and the y-intercept. The x-intercept happens when y is equal to 0 or where the line cuts the x-axis. Right? Now, they like to ask this question, right? So there's nothing to work out really. If we look at the line L, this is the line L here. The line L is coming down this way and cuts the x-axis at this point, 6. That is the x-intercept is this point here. This point here, y is 0, x is 6. So that the coordinates of the x-intercept we'd say here A part 1, the x-intercept. This is really a point, right? This coordinates happens at the point 6, 0. This is my x-intercept. Right? This is where the line is cutting the x-axis. And the same thing happens to the y-intercept of M. Y-intercept of M is the point at which it is cutting the y-axis. So it happens where x is equal to 0 or where the line cuts the y-axis. Now, any point on the axes, like any point on the x-axis, will always correspond to 0 on the y because the x-axis is passing through 0 on the y. Similarly, any point on the y-axis is passing through 0 on the x. Right? Everybody can see that? So for part 2, the y-intercept is the point 0 minus 2. Right? So the intercepts, they are points, they are coordinates. See, they say write down the coordinates. So a coordinate has an x and a y value. For the x-intercept, the y value is always 0. For the y-intercept, the x value is always 0. Right? So that's just a common knowledge that you have to know. It's like your times tables and thing, right? Once you know that, you just have to watch the graph and extrapolate right down the values, the coordinates. Remember the x-intercept, y is 0. The y-intercept, x is 0. The opposite is always 0, right? You look at the graph, you're looking at for the point at which the line is cutting the x-axis if you're doing the x-intercept. You're looking for the point at which the line is cutting the y-axis if you're doing the y-intercept. All right, everybody okay with that? Right, so I'm moving on to B. The line L is given by the equation x plus 2y minus 6 is equal to 0. When we're doing coordinate geometry and we need to use the equation of the line to find a missing point, the equation has to be in the form y is equal to mx plus c. So we want to rewrite as y is equal to mx plus c. In other words, make y the subject. So if I start with this, I could move this 6 to begin with. All right, if I do that, I put back everything that's not moving. I don't need to rewrite this 0. I could just put a negative 6 in. Then the next thing I'm going to move is the x. The x will become negative x minus 6. All right, and then the last thing I'm going to move is the 2. But when I move the 2, each of these here have to be divided by 2. So it's going to be x over 2 minus 6 over 2. And I just need to clean this up a bit. X over 2 is the same as negative half x. And 6 over 2 is the same as 3. 2 could go into 6 3 times. All right? So this is the equation of the line L. Now, we are given a point, 9k. So if you want to find the missing value, which is k, remember this is our x value and this is our y value. We could substitute the 9 into this equation to find out what y is. So if I put 9 in here, half of 9, negative half of 9 will give us 4.5 minus 3. We keep these signs and add, we get negative 7.5. So k, this missing value here, which is really the y coordinate, k, is equal to negative 7.5. Yeah, everybody all right to now? I'm gonna do part C underneath here. All right, so just one minor change. I forgot to change this to positive 6 when I carry it across the equal sign. So that means that here is going to be positive 3. So if this is positive 3, negative 4.5 plus 3 is actually going to give us negative 1.5. So our value for k is negative 1.5. Right? So that's the value for k when x is 9. And we reroute or we change the form of this to y is equal to mx plus c. Yeah? All right. So let's talk about part C, which is to find the equation of the line M in the form y is equal to mx plus c. Now remember, we need the gradient. And we need 1 point on the line. We don't have the gradient. We wasn't given the gradient. All we have is the line M. Minus little proper footer. Just trying to highlight it. Right? So we need 2 points on this line that we could use to work out our gradient. I think I could use this one here, right? This point is in line with 3 on my x and 4 on my y, right? And we could use any other point. It doesn't have to be any particular point. Look at have another one here. That's the point 1 for x and 0 for y. So that's the 2 points I'm going to use, 3, 4 and 1, 0, right? So just choose any 2 points that you can easily identify on the line, right? Because we need 2 points in order to work out the gradient, and then we'll just use one of them when we have to work out the equation of the line. So I am using 3, 4 and 1, 0. This is going to supply me with x1, y1 values, x2, y2 values to find my gradient first. So m is equal to y2 minus y1 over x2 minus x1. So y2 is 0, y1 is 4, x2 is 1, x1 is 3. So m is going to be negative 4 over negative 2. So m, and negative divided by negative is a positive. 2 into 4 is 2. That's our value for m. And then I think for finding the equation, we will use m to be 2, and I'm going to use 1, 0 for my x and y values. Right? That's an easy one to use. So y is equal to mx plus c. Y here will be 0. M going to be 2. X going to be 1 plus c. This is 2. So c has to be, when I carry the 2 across, negative 2. So equation of m will be y is equal to 2x minus 2. Yeah? And that's how we're working out part C. Everybody right with that? Now, for part D, we want to show by calculation that the line L and the line M are perpendicular. So to do that, we need to take note of the gradient of L and M. If the products, meaning that if you multiply the two gradients, is equal to negative 1, then they are perpendicular. So let's see. Gradient of M here is 2, right? And gradient of L, we go back up here. This is the gradient of L here. Remember, negative a half. We multiply the gradient of M multiplied by the gradient of L, 2 multiplied by negative a half. That's giving us negative 1. So the lines M and L are perpendicular. So again, this one is more about theory or concept or rules, as opposed to working out something. Just like you have to know the how to find the intercept and how to find x and y's intercept. you have to know the rule for perpendicular lines, that the product of their gradients is equal to -1. So if you have to show that, you multiply the two gradients by each other. And if you could do that and get -1, then the lines are indeed perpendicular. Right? Part E, they want us to solve the simultaneous equation. So there's no working really to do here for that, right? To solve a pair of simultaneous equations graphically, I'm taking off these from here, right? We look for the point of intersection. Where the two graphs intersect, cross each other, that point, the coordinates of this point here is going to be the solution to the simultaneous equations. So we're talking about x being 2 and y being 2 as well. Right? If it was crossing at some other point, let's say it was crossing here, and you got x to be 5 and y to be 3, then that will be your answers to the simultaneous equation. It would mean that the solution is x is 5, y is 3. Right? If it was intersecting here, then x will be 8, and this will be 5. Y would be 5. Everybody understand that? So for this particular pair of equations, if we have to solve them using the graphical method, we're looking at where the two lines intersecting. And you take a note at that point, and you find the coordinates of that point. So the coordinates of this point is the coordinates 2, 2. And we will write solution to the simultaneous equation is x is equal to 2 and y is equal to 2. Yeah? And that's it.